welcome everyone. It's my pleasure to have Maximilian Schich here to give a talk in our CHM seminar. Maximilian is a professor for cultural data analytics, which is a very fancy word and new research area, and you will talk more about this. I think the basic idea, and this is easy to state, is he and his team try to uncover laws and more or less universal pattern of cultural change with very different methods, ranging from concepts and expertise in art history, computational social science, network science, complexity science. Maximilian is an art historian, and he also studied classical archaeology, I guess, in Germany and Italy. And then he went on to do postdocs with Dirk Helbing in Zurich, I think, and Laszlo Barabash in Boston, where you did network science, and specifically you applied network science to historical data and to art history research. And I think this collaboration then resulted in a very nice paper where you essentially established concepts or a framework of network science in cultural history. And there, the idea was really to take a data set of people, where they were born and where they died, artists or other people that are supposed to drive cultural change. And from that, you could map a network, and analyzing this network, you could then say, what were the cultural hubs at the time? How were these pattern of cultural hubs changing? And you could also uncover different other interesting aspects of individual characteristics in these statistics. And then in a very recent paper, you zoomed in more. So you took not this macroscopic view, but you were analyzing how visual and aesthetic complexity evolves over time. And I think, yeah, I like this paper as well a lot, because I think here at the center, we are also interested a lot in how to come up with mathematical description of cultural items and cultural complexity. And I think, yeah, this will stimulate a lot of discussion afterwards. Overall, I think it's inspiring to see how you tackle cultural change along different dimensions and across different scales, covering the whole globe, looking in the past and the future. And yeah, I'm looking forward to your talk and for the discussion afterwards.
Thank you very much. So it's a very great pleasure. I already had a sort of half day of discussions with some of you, which was super, super inspiring. And so thank you very much for this opportunity. This is Iyad and I, we met the first in Boston, very much Boston culture, which is amazing to see in Europe. It's not often found in that kind of sort of welcoming openness where one really, works across disciplines in these ways and like sort of has this open doors. So this talk is called Cultural Data Analytics Meets Humans and Machines. So what we do in this Cultural Data Analytics research group is very much sort of academic mixing of disciplines. And we have an event series going on, sort of tasked by the European Commission, which we call the Open Lab Seminar, where we do lectures and we also do what we call lab encounters. And lab encounters is basically some other group coming in, telling what they're doing. And so I will try to sort of represent my group in the same way. And this is I think it's the second time this happens, that this is sort of done the other way around in a very formal setting. And I think this is the basis of a lot of potential future collaboration, because we all need to find out what other people do. Particularly as we work between disciplines, there is no textbook you could look into and say like, okay, what do art historians do with network science? It just doesn't exist. Fun fact, what you see in the background is the Pirita beach in Tallinn on my way to work. And so there is substance, so there's rocks from the Ice Age that are sort of 1/f distributed. And you also can see this sort of like residue, obviously it was too slow, of some kind of Kelvin-Helmholtz instability on the fog on top. So that's sort of like the two topics of this. We have discrete things in culture, and we have continuous things in culture, or continuous media in culture that have some kind of dynamics going on, but it's not arbitrary, it's not random, it's not average, it's not sort of always anecdotal. There's some stuff that actually, you can look at this fog and it's like, yeah, that's like sort of Kelvin Helmholtz. It's amazing. And so in a similar way, we try to do the same thing for culture. So let me give you like a little, let me put the elephants in the room on the table. Let's put it like that. So what you see here is from this second paper we was just talking about. What could this be? Right? Could be cells and the lines and some kind of expression of whatever on the vertical. It could be, I don't know, countries in one direction and products that are produced more or less in the other direction. This is actually, every column is a painting and every line is a particular compression size of the painting after some transformation, and always in the line is always the same compression. What you see is the biography of Piet Mondrian, who for a long time in his career did super mainstream sort of naturalistic paintings, and at some point he did, you know, the usual checkerboard with red and yellow and blue kind of thing going on. And so here you can very clearly see where this happens. You can also see other interesting things which may be anecdotal, like for example, you can see these kind of correlations, like this painting and this painting has something similar going on. I don't know what it is, we would have to look it up. But a key thing is this picture gives you the anecdotal stuff at the same time, a general pattern that is like sort of some kind of second order phase transition, whatever, in his work, but it also systematically gives you something else which we can study. So the key point about this figure is we can quantify culture. It's possible, and there is some interesting stuff going on. I will talk more about this later. There is networks in culture. This is, every blue thing is a statue, every brown thing is a document, and you can see there is a kind of maybe exponential or scale-free distribution of connectivity going on. So networks is actually something that's going on in culture, and they totally make sense to study with the usual tools of network science. But then there's this other thing, which is totally not networks. So what you see at the bottom here is from a book called Structures of Complexity by a guy called Rupert Riedel, who, if you want to get a, you know, if everybody talks about evolution in your group and you have not catched up on that, and you want to have a really cool cultural history of evolutionary theory, Rupert Riedel wrote a really entertaining book about this, unfortunately in German only. So this book is his summary of complexity research. I say it's a research, not science. Which in his mind also includes culture. And so he gives things like that. What you see is plates, some imaginary, some really existing. He calls this form of picture a similarity field. So I want to just drive the message home. It's a two-dimensional picture of some high-dimensional rim width, depth, form, whatever, of some high-dimensional category system that's boiled down to two dimensions, which doesn't always work very nicely because, you know, it's not that you have gradients in all directions. You have some kind of cliff going on here where it's more gradual in this direction or more gradual around here. And obviously what this sums up to, if you think long about it, you get these kind of energy landscapes. This could be epigenetic landscape. It could be the separation of words, word meanings and word net and stuff like that. But there is also some other thing. Anything you embed in multidimensional spaces, you can sort of think about it in this way. And then again, this becomes a subject of analysis, much like networks can become a subject of analysis, with the big difference that this object here is continuous. And then there's this other thing which you may be surprised that this happens a lot. In humanities fields, you have to drive home the message that time temporal patterns can be quantified. And, you know, there's this old notion that the Geisteswissenschaften are event disciplines. They're always special. There is no such thing as like patterns and fundamental laws. So here, every dot is all the Flickr pictures over 10 years that are shot in the city of Rome in a particular minute of the day. And they sum up to this black line sort of, which is the standard human activity curve. We write emails that way, we print documents that way, we sort of, you know, do phone calls this way. We obviously seem to take tourist pictures this way. If you want to understand if this picture here with two bumps, which is the Vatican Museums, is sort of special or not, you need to know the null model, which is this sort of like average kind of thing. the fact that in the evening people do stuff at the Fontana di Trevi will not stick out at you if you see only the blue curve, because you would say, oh, most of the stuff happens in the afternoon. No, it doesn't. It's like sort of regular. You would expect that. But what is really overexpressed is that people stand there at 10 in the evening all pretending to be Anita Ekberg or waiting for her to show up. The stuff here is American tourists who don't change the time in their cameras. I could talk about this in the upper left. That's a similar curve. That's myself and my wife taking pictures and then running out of battery. So that's called art history. So these patterns boil down to something which people like Rupert Riedl knew for a very long time. And they were very explicit about it. Cultural production is also a branch of complexity science. So you can see for Philip Warren Anderson and XKCD, who doesn't cite Philip Warren Anderson, but he's totally like, that's like the same thing. For them, social science and psychology are sort of like the upper level of, basically where the integration of granular stuff ends. But Rupert Riedl sort of had this idea. It says, okay, people produce stuff, and that stuff has complex patterns. And this is, I think, very fitting for the group here. That stuff interacts with each other. And so if it's machines, they have behavior going on. So then you get already something interesting. Let me give you an example of a very simple cultural interaction among cultural products. If you are a museum and you're interested in the history of ski boots, they're at some point not made out of leather, but of plastic, and you put them in the same cupboard. And 15 years later, somebody wants to write a PhD about this. They open the cupboard and all you find is like some pile of rubble. It's because there's some quasi-metabolic interaction going on between the sort of organic compounds in the plastic. So that is also happening. So not only is sort of some kind of, we not only find creative complexity in cultural production, but there is also interaction of decay. And that is a very important thing if you're studying archaeology and art history. Decay, ruin state, is a very, very important thing to look at, which also is pink noise distributed. So here's the problem. What we do necessitates true multidisciplinarity. And this is my favorite picture with which I introduced that. So what you have here is a picture of co-occupation based on 2.1 million people in Wikidata and Wikipedia in all languages. And so this is sort of weighted, and there's some sophisticated pipeline going on. It's done by a guy called Doron Goldfarb from Vienna in my lab, then in Dallas. And if there is a link, one person has 2 jobs minimum. And you can see there's these clusters. There's the object disciplines, which is architectural history, art history, archaeology, Egyptology, anthropology. Then here's theology, writers, philosophers. Up here you have the creative. This is critical aesthetics of objects. This is creative aesthetics, painters, information visualization people, and stuff like that. And then fully separate of these two, again, there is the people who quantify, mathematicians, physicists, computer scientists. Social scientists are somewhere here. They're also separate. They're a little bit closer to the quantification people. But the reason I'm always showing this picture, imagine you submit a paper and the editor has to decide who they invite for review. What do? They invite, maybe they know a cultural evolution person who is somewhere between mathematician and social science. But if you talk about art, they're gonna invite some art historian. They're gonna invite some English literature, Shakespeare specialist, right? And the probability, as you can see, that that person also know what these people down there do is essentially 0. So the key thing is you get 2 reviewers. One says like, that's not what I'm doing. And the other says, that's not what I'm doing. And then you won't go over threshold and you won't be published. So the key thing is we're trying to bootstrap a community that makes sense of cultural production and maybe cultural creativity in a world where we're sort of like fully separated, maybe connected via some wormhole. I don't show that picture, I could do that too. there is these wormhole disciplines, computational social science, complexity science, network science. We all, in a UMAP of all academic disciplines, we all end up in the same spot. We're not a cluster. But if you just take that wormhole and you're like, yeah, it's this, yeah, we all hang out at the same conferences because we go to all of them, of course. And so that is an interesting thing about this. Now, how do we bring this together? And here we take a lesson from fluid dynamics. So imagine the black square is a fluid. The white is also a fluid. If you want to mix this, you have to stir it. And so this is, by the way, a reversible process. So if you here and you reverse the stir, you would end up with that square again. If you do this a lot, you end up with this kind of picture, which is it's called striation. So your layers become very, very thin. And at some point, they're thin enough that sort of any atom in your black layer can diffuse to the white layer and vice versa, so everybody can talk. So the conceptual notion we take out of this is that we bring people together in a room and then fold sort of out what we're doing enough so basically the concepts become compatible. I'm not showing this right now. I could also say that putting energy into the system to mix, if the geometry is wrong, like if the mixing vessel has the wrong shape, will actually demix the system. So if you put a computer scientist in a room and a humanist in a room and you force them to talk, there's a much higher probability they walk away and say, well, I don't want to have anything to do with this other person again. So what we do is difficult. So if you take a little longer for a publication, whatever, this is the usual part of the process. One fun fact, Julian Emotinio is the head of the Northwestern School of Engineering and also the founder of the NICO, Northwestern Institute of Complexity Science. So this thing is sort of, there is some kind of design behind this. So there's this inspiration doesn't come out of nowhere. He confided to me once that, you know, I'm a painter and then I became a chemist. So he figured out how colors mix. And then I stopped doing that and now I'm mixing people. So that's where that idea comes from. And so this is sort of the premise for this thing. Tallinn University applied to the European Commission. They said, we want to do cultural data analytics. And we want to hire somebody who does that, who builds a group and sort of throws tentacles across the university. So we become more, not a siloed structure, but so we basically sort of interact across the departments. And so they took 1.5 years and they hired me in June 2020. The 2.5 million euros were originally for 5 years. And so I was able to extend the project, or the European Commission was generous to do that for us after we were asked cautiously. So we'll now run till August 2024. And so how do we do this? So I went to the market, so to speak, meaning I tweeted this picture. So this is not a picture you would put in the Frankfurter Allgemeine Zeitung or, you know, somewhere where it's for plenty of people. But for people like you, if you start searching in this picture, you will find places where it's like, that's interesting. And so I was searching for people who had that kind of reaction to this picture. And so where does the inspiration from this come from? The left 2/3 are basically, if you would open the lid of IBM Watson for Jeopardy, that's basically what's under the hood. There's some machine learning of images on top. So you embed images into some space that produces obviously some kind of activation matrix, which you could do artificial neural science over time and stuff like that. You would have texts that would be embedded, like with topic modeling or whatever. But here I would like to say that topics and texts is just the most general version of, you can have the shortest text possible is basically the title of a book. And sort of you can assign topics to that. Library classification is basically nothing else. We're talking about bipartite networks, where then we can do things like we can turn them into a morphospace of things that are connected with each other. And that is also something one could analyze. And then the third layer, which is neither text, neither linear media, basically, nor sort of, you know, more complicated audiovisual, could be music, whatever, multi-temporal media, you could say. There's this other genre, which is knowledge graphs, pure topology, like a knowledge graph such as Wikidata, for example, has multiple node and link types, so it's not a pure bipartite classification. And there, again, you can ask yourself, can I classify this? The people do graph embedding right now. This was like not, this is like coming up as we go. And then you could imagine all of this could maybe embedded into one space. And then we could actually have some kind of cultural meaning space and look at the evolution of that. So this is a cartoon picture, okay? It's just a problem setting. And so here are the people who reacted to the call and who we did hire. And you can now forget about the picture. I will show you what these people are doing. And from that, something will emerge, which may at the end resemble this picture, but it may also end up being something completely different because what we do is new. And so all of them are sort of open towards embarking on something that is outside of their own discipline while they have an expertise of a discipline, and very strongly so. So Andres Karius is a computational linguist. Xenia Mokina is a computer scientist. She does these kind of multimodal embeddings of geo, social, visual embeddings. She had an app on the last Soccer World Cup where if you were in Russian city, you could in real time know where the party is, where people post the most Instagram picture. Mila Oiva is a cultural historian. She works on pseudo-history and the history of Soviet newsreels. Vijuna Tsimaitite is, she says, she calls this industry-facing cultural industry researcher. So she works with film industry data, looking at the gender problem, which is rampant, as you know. I recommend there's a Neo Magazine Royale episode by Jan Böhmermann about how many men are in the German film industry making film about men problems, only men are paid and stuff like that. It's horrible. So that's exactly what's going on globally. Mikhail Tam is a physicist. He was originally a physics professor at Moscow State University. He joined us as a senior fellow to do social physics. Tasvir Ahmad is or was a senior fellow. He just left us for family reasons. He's doing high throughput object recognition in images. So if you have lots of images and you use something like YOLO in what's called difficult images, like paintings are basically, if you take a naive perspective, shitty photographs, if they depict a horse that's sort of horsey. Jana Sachi, which some of you know, which I find awesome, is a PhD student. He has a background in human-computer interaction. He's an entrepreneur with a dating platform. He's doing his PhD with us on online social media, and you may be surprised that PhD is in the humanities. So he recently joined the MIT Media Lab for a couple of months, together with Levin is there at the same time. So that is a really fortunate kind of thing. Here's Mark Hannes-Swola, who's an artist. And so he and his wife, they're called Var and Mar, so Varvara and Mar. They're machine learning artists. He's doing his PhD with us, but he's very well known in what he's doing and definitely has his act together. So yeah, so it's sort of, as the PhD advisor, I have to say, it was like, there's some people you're like, yeah, I can say that's good. That's about it. Hanna Yema is a PhD student in media policy studies, very interview-based, sort of analyzing the data usage in legacy media institutions, which is a huge issue. So if you want to actually do data analysis with, say, public service media like ARD or ZDF, you also need to know what they're actually doing. So you need to talk to them. So that's basically what she's doing. Mark Metz, he is originally a very qualitative semiotician. Cultural semiotics is a big thing in Estonia due to the presence of Yuri Lotman. Yuri Lotman was sort of like, if he wouldn't have been in the Soviet Union, he would be in the same realm as Bertolt Lundfield, people like that. He was close to that kind of school of thought. all of Estonian society is sort of infused with this semiotic thinking, which even if you don't speak Estonian, you can walk into a supermarket, you'll find everything, because it has been analyzed how it should look like semiotically. So if you are having a decently working supermarket in your home country, and you walk into an Estonian supermarket, you will find the stuff. So, and this is actually permeating Estonian society. It's quite fun. There's another link to us, which is quite interesting in complexity science. There's another very prominent figure in Estonia connected to semiotics, which is Uxküll in biosemiotics, who coined the word Umwelt, environment, and who also was, as far as I know, the first person who drew a feedback loop between the individual and the world, with a second feedback loop internally, having a model about that world. So you have this thing going on. And he called this a Wirkungskreis. And so there's this deep tradition, but now Mark, what he's doing is basically natural language processing, looking at polarization in Estonian text. He's currently with Peter Dodds at Vermont Complexity Center. Tilman Ohm is an artist who did his diploma thesis, not himself, but he built a machine who wrote the thesis. So all the bibliography, all the images, all the text was written by a machine. And now what he does with us is sort of like the Galore version of that, to sort of help curating and understand multidimensional meaning space. You will see some images. And this is Antonina Korepanova. She's a painter. She started her PhD about art education in 21st century art school, but then unfortunately took a course with us. And then she got hooked with scraping the internet. And she started asking permission to museums for the data once she scraped it. No, that's not true. She asked, and then she scrapes. And so now there is a study in the pipeline that is about the evolution of museums. Like if you're an artist, you want to know, when does the museum buy my works? Like, can I sustain my kids with that? Or will my kids be able to sustain their kids and I will die poor? And it turns out if you're French and you're in the race for getting bought by Centre Change Pompidou, you will die poor. Well, if you're, sort of in a Scandinavian country and Kiasma may buy your stuff, so for example. So here is the same thing with pictures. And here's something important to know. So every one of them leads at least one project. So they have a home thing that is them, but they're usually the first author, and then others in the group, other faculty at Tallinn University, and that's not necessarily me, and other people outside are co-authors. So whenever I say in the lower left here, et al., that basically leaves out the entire village that was co-responsible for doing that kind of stuff. So in this particular case, on top, this is a research of board co-membership in the Scandinavian, Nordic Baltic screen media industries. This is work with Professor Ulrike Rohn. And then down below here, this is a part of the Newsreel Project, which, as you will see, is led by Mila, but there is a lot of like gender encoding of Russian names, which has been done by Xenia and so on. So there's really a sort of, it's always like this kind of mixture thing going on. What you see down below here is the gender, that's the color, like this magenta thing is female and the green thing is male. In the cinematographers of Soviet newsreels in the Soviet Union over decades, and you can see at the top level those who have, this is just, the nodes are just sized by degree. The people who were involved in the production as directors or leading camera people of these newsreels, on the top level, we have gender equality or even a majority of females. While if you look at the bottom, you still got 85% men. So it's this sort of like outward facing, look, we're sort of this equal society, but actually like literally that one step down, you get the same kind of bullshit going on as in the West. This is Another example from this Newsreel project, where we basically have now every frame of one series, there will be other series, 50 years of basically newsreels. And so this is just some T-SNE map. And this is just to say, Mila Euber is a cultural historian. She, at the same time, sort of like administers the collaboration with everybody in our group, plus some other people, towards the aim of like, what our goal is to have a kind of framework paper. What is possible in this kind of realm, from qualitative exploration using something like a tool that Tillman built with MAR, to, at the other end, sort of like machine learning object recognition, looking at time ranges and stuff like that. How does stuff move in space? This is a really interesting thing, by the way. So let me give you, based on the discussions we had before, we're talking about artworks in multidimensional space, like artists moving through multidimensional space. Yeah, just think about how this works for this. This is really, really interesting. Much more data. This is Tasvir. So here you see some difficult pictures. So yeah, you can recognize a train here and a car there. So basically that's the idea that he has this kind of improved version of YOLO 5, which is you only look once kind of pipeline with gradient boosting to sort of try to, in a limited data set, nevertheless make it recognize certain things. And the one take home I have from this project is that most of the machine learning stuff is so focused on human bodies, it's almost disgusting. Because what is this for? It's for surveillance and for killing people. And all the other stuff we know very little about. That's really sad. So we should be interested in the other stuff, because then we would find out more about people. And we would not just say, oh, he looks like, and then they're gone before we actually had a chat. Here you have Jan's work. So this is two projects he does. Let me start on the right, because it's actually an earlier project. So this is sort of some UMAP embedding of all public Tinder accounts in Estonia. Again, the two colors are gender. And you can see there is sort of like the different distribution of confidence that a certain profile is male or female. And then there's about a third of the data which is basically like the sum of the other two that is sort of unassigned. One of the interesting things is that the outliers are really very prototypical or stereotypical, like some dude with a beard, and on the other side, it's very interesting. It's sort of a type of some female with long hair that has here's the artist story, like a Salzburg Madonna that has a kind of S curve in the body pose. So there's a kind of, it's really almost like a conventional artwork. And in between, the interesting thing is that there is a lot of things to be found which you wouldn't expect whatsoever. Like not androgyny, but two people in front of a car as a self-expression on a social media platform that is there for dating. So this is sort of really interesting. And so, yeah, this is a very interesting work, which obviously you can imagine we had to go through ethics approval. None of us looks at the actual images except the first author, and then also basically mostly through the eyes of the machine, because we're very much taking care that this is sort of within ethical realm. This is not about spying on people. It's about like trying to find out what sort of the general patterns in the system are. And on the left, you see this is work he has going on with Mark Connett, which is about features of Bored Apes, where very few features are coupled with the price, which is now either 0 or 0, I guess. But so there's an interesting thing shaping up too. So that is something which is also interesting, that there is the shared interest of people interested in social media, people interested in art, people being fully embedded within the system. Like Mark Connett is sort of, you know, you will see his, if you look him up, he's sort of like in the top 500 players in this kind of AI art place. And so there is a very interesting thing that he has sort of an access to that landscape that you would usually not have. And so that is quite interesting too. Here, this is a sort of flower bouquet of works by Andres Carius. And Andres is a computational linguist and is also super talented in R. So he teaches courses of how to do stuff with R. And so it's very, very fast in doing that kind of work. And so you can see a number of things. So on the top right, that's a decade of global film festival networks. So films that make it to the same festival. There we have the database behind the Cannes Film Festival. So it's not just Cannes Film Festival, but all the other festivals these movies also go to, including the video on demand data of the people who watch the movies and then decide they buy the movie for their country. So this is a tiny plot from a huge project with plenty of people. This is from the compression ensemble paper. So this is art over time, in this particular case, general texture and complexity. And you can see that sort of this is widening, so less complex and more complex art turns up since 1900. And by the way, actually here, every dot is the actual dominant color of the painting, which in this resolution you can't see, but this is really interesting because if you zoom in and you know how 19th century watercolor boxes look like, it's exactly these colors. And there are some colors that just don't exist. Then this is a year of post-election Twitter. This is basically polarization. This is coming up with Chrissy Koskinen from Exeter. And here you have 2 decades of programming in public television. So here we have the entire programming data to the minute, or actually second, of the public television in Estonia, which is, so basically this is like ARD, ZDF, this is like some third program basically. So this is first and second. It's more like ORF1, ORF2 in Austria, and this would be the Russian channel, which they founded in 2014 as a reaction to Russia invading Ukraine on the east. And then the big issue is obviously you need to produce Russian-speaking content, obviously coming out of the countries where you have a Russian subpopulation. And that is really hard to hold up for the sort of not so rich countries in the East. So they also had to buy in stuff from Russia. And so that is you need to think about that, right? So basically, it's not only a measure of self-defense of Europe to sort of have sending them out in German here, but there is a kind of thing, there's an issue we need to sort of give sort of sober news to people who speak Russian. This is work by Mark Metz. This is polarization in a mainstream news outlet, the largest in Estonia, and a right-wing news outlet. And I like to just, this is not fully done, but I like to give you one little take home. The polarization is not between negative and positive, in this case, opinion about migrants, but it's about negative and neutral. There is very little positive said, even in the mainstream media. This is a really interesting thing. It's because sort of the larger outlets try to be balanced, quote unquote, whatever that means in this circumstance. Here you have Ksenia Mukina's work right now. She's looking at millions of Instagram pictures in museums. So here you can see 12. And this is just also one simple thing. Here you have a year of the Dallas Museum of Art. We have these spikes, which are events. And then these is sort of like the daily rhythm, sort of the average number of pictures posted in the hour of the day. Here's 24 hours in particular art museums. And I find this super exciting. We've done, this was finished last week. You can see some of the large museum, Prado, British Museum, Museum of Modern Art, have the same shape. Louvre Abu Dhabi is shifted out of phase. That seems to be because the stopover time for tourists is like sort of in the wrong location. There's other places like Louvre-Lens. My favorite question, who does know Louvre-Lens? Nobody, right? So Lens is a tiny town in the northwest of France, which has a huge soccer stadium and a Louvre, including good artworks, but nobody shows up there, as you can see. And you can also see that, over time, the number of pictures goes down with the pandemic. So we have the pandemic, So we don't show you that here, but there is obviously, we have the fade out envelope in the museums. How long does it take until there's really no pictures posted, which in some cases takes sort of 6-8 weeks. So there's no way to get into the museum, but people still post from the place. And we have gotten rid of all the spam and stuff like that. So it's a really interesting thing. So there's a very long lag seemingly sometimes until people upload the images. This is also museums. This is now to the left. This is also brand new. The age at which artists produce their artworks, where you see there is sort of kind of, the median is around 40. And on the right, you see the time at which the museum buys the artwork. And I like to, just look at the sequence of museums, and you can see that the low gap is 15 years and the high gap is 50 years. So this is a really interesting thing to look at museums. I don't tell you what the axes are here. This is just a teaser, but this is, I said I was like, this is a violin plot. It's like smooth out. Can we have the raw data? I want to look at the raw data. And so here you can see sort of the matrix version of this. And so we can see these museums are very different. So these things sort of look, in some sense, the same. You always got this diagonal going on, but other than that, there's some other things going on, and obviously we want to figure out what that is. This is Tillman, and so one of the core thing everybody's itchy for, including museums where he's presented this already, is this thing called the collection space Navigator, which in some sense is a continuation of his work and also something that naturally fell off our compression ensemble paper. So you have a cartography that's two-dimensional in the middle, could also be 3D, and then we have multiple dimensions on the right. So you can look at your questionable topography, UMAP, TSNE, whatever, and then you can filter it via other dimensions, and that you can see the dynamics. That's pretty cool. And so Mar and Tillman, or Tillman and Mar, they worked to implement this, and so it's done in Node.js, and it's really reactive, it's really fast. So you can load it up, a data set with, I don't know, 65,000 images, takes like a minute to load, and then you can play with it, and it's super instructive. Obviously, this leads to the problem that how do you even imagine or project these embedding spaces into 2 dimensions? And here he plays around with sort of like how do you sort of a 12-dimensional depiction and stuff like that. But then there's other things going on. This is like his early first algorithmic curation based on knowledge graphs, and the stuff he's currently doing is sort of we explore the stable diffusion space. And so what you see here, you pick an image and then you look at the nearest neighbors. And again, this gives you a notion of like, what's the structure of the space? Because that is one of the key issues, which I think is really important. Have you ever realized that the oldest quotes in deep learning textbooks are behaviorist work, like Skinner and stuff like that? Skinner famously is famous for to not give a shit about what's going on between stimulus and response. While those of us who are more bent towards cognitive science say, and know that the cognitive revolution was not really new because they just forgot to read Wertheimer and Helmholtz and like all these people, there is something going on between stimulus and response. Even more so, these machine learning models like stable diffusion or whatever, you can open lib and you can look into it. You can actually see what the values of the neurons are, in this case, not neurons, but if you have something like resonant 50 embedding. So the key thing is we can actually now take a look. That's a huge advantage because my favorite example is if you have an fMRI scan of the human brain, that's like studying the sex life of squirrels on a 500 meter per pixel Landsat picture. You don't know squirrels, this may totally influence the greenness of forest. If you can prove that, that's cool, but it totally doesn't tell you everything that's going on. But here we can. That is really, really cool, and I think we should do it. This is work of Mike. Let me look at time. So this is work of Mikhail Tam. And this is just an example on the left, sort of like the explanation of why you should have a physicist doing cultural analysis also. A very simple example on top, it's just, you know, city population versus how often is that city mentioned in Soviet newsreels. And you can see that certain places are over and under expressed over the square root deviation from the diagonal. And I just want to, you know, point to the fact that posh places, privileged places like Tallinn, Riga, Minsk, that were relatively Western, relatively, you know, the Baltic countries were privileged in the Soviet Union because they were so afraid that they would turn against them. Because, you know, people there could watch Finnish television and stuff like that. So they had privileges like, you know, a little bit more exchange with the West and stuff like that. While the underexpressed places include places like Donetsk, which is bombed right now. And there is others of these places. And then there is places that are sort of like coal mines, you know. So this is one thing. This is basically Michael Betti, Louis Bettencourt style urban science. It's sort of straightforward. But then the reason I actually said, I argued for, I really want to have a physicist, is what you can see down below here. The notion that the embedding space is a mathematical object that we need to sort of like grasp what it is. And everybody has this problem that we cannot imagine what it is and how does it work. And so what you see here is it's 10 paintings that are transformed in 100 ways. So you have 100 shitty versions of 10 paintings. And then you say, can I disambiguate all the Van Gogh Starry Nights from all the Mona Lisas, even though they look bad the same way? Like the black and white Mona Lisa should cluster with the Mona Lisas, and the black and white Starry Night should cluster with the Starry Night. So how is this possible? So this is, if you look at the plain PCA1 and PCA2, so you get these confused clusters. And so Mike's idea was that the dimensions are not renormalized in the right way, because even like, and this is obviously a simple assumption, you imagine the values are, even if they're linearly distributed on the axis, it could be that one dimension is naturally much shorter than another dimension. And so what he does is he just rescales that locally. So out of these clusters, which may be elongated along one axis, they become more spherical. And that actually changes the picture. So the principal component actually separates the cluster much better into something that awfully looks like a quasi-species. And obviously, if you take a 3 or 4 dimensional version of this, then you can really see these sort of like balls of dots in the space. Now the big problem is, can we extend this beyond 10 paintings? Or if you take, the first question is now, let's take another 10 paintings. Does it still work, right? And then not only does it still work, can I do the same renormalization and it still works? So there is, it's a really very, very classic physics problem right now. Okay, I could stop here or give you a little glimpse into this paper, which some of you have read, which is great. And I got nice feedback today that was really cool. Maybe let me just jump into one kind of picture here. So we take a painting, we transform it, in this case with image magic transformations, arbitrary number, in this case 120, so this is some of them. You could also do it with OpenCV on the GPU, but we did it with image magic because we're lazy. And then every one of these transformations is compressed and divided by the original size, so you get a compression ratio, so it's normalized. And then this gives you this kind of matrix. If you do this with 65,000 paintings, you can produce a similarity field. And I'd like to remind you, it's the same construct that Rupert Riedel had by hand, and it's the same construct you get if you do a UMAP of a resonant 50 network. And even though we don't have objects, we still get some correlation. And locally, it makes sense. If you cut out a little circle, you get paintings that are fairly similar. It's a vector space. you can add and multiply with this. So you can add the garden of love to some trees that are woodcut prints, so you get a garden of love that is woodcut print or whatever is close to it in 65,000 pictures. So it's a really interesting thing. But now here's the thing. We got these transformations. And you get this. This is not, this is something where I could say, you got, I need to stay at the microphone, I guess. You got some fancy pipeline that costs a lot of energy, but this still costs a lot of energy. And then you get a similarity field. So what? So actually what we have is we know the dimensions. They're explainable, right? And now what we can do is we can take this similarity field as an imperfect topography, two-dimensional depiction of the system, and ask ourselves the question, how much does a particular transformation contribute to the position in this place? And then it turns out that all of them, so here you see heat map versions of that UMAP, and the color gives you if particular values for blur, for example, are more compressed or less compressed than average. So you can see all of them look different. So all of them contribute something to the understanding of the picture. And this is sort of like, this is why Sebastian Arnold and I worked on this since, there's an anecdote. We sat on a park bench in 2016 at UCLA, and we're sort of feeling really bad that this is not out yet. And so we never had the time, and then along came the CUDAN project, and I hired Andres Karius, and he was talking about something similar, and they said, like, we got this old project, can we do this? And so we did it. And so now we have sort of what, from our perspective, is sort of the first explicit version of what Wittgenstein called polymorphic family resemblance. So with this thing, you can recognize a poodle from a cat. Not quite as an object, but sort of the style of it. Without any machine learning, there's no machine learning. That is a really interesting thing. And that also means, because we now have the dimensions defined and we have this sort of embedding, we can also compare this with machine learning results. And as you know, there's like a very small crowd, relatively speaking, to all the posters in Europe, but there's a small crowd of people who tries to understand the space. And that is sort of where this is going. And it's not perfect because we don't do segmentation for object recognition stuff, but it's still one step. And I encourage you to read the paper, particularly the discussion gives you all the links to all the disciplines that are relevant. And like one other relevant place is that there is a sort of alternative cognitive science by a guy called Peter Gerdenfors, who has a realistic idea for certain things, at least, like colors are more imagined, not like the categories, but like sort of some geometric space where there is some vector space where we can locate ourselves. And so this gives you exactly something like that. And now the question is, what are the dynamics of this? Another route which I'd like to point out is, and this is very, very much where I'm coming from, my PhD is on a data set which was started in 1947 as a reaction to an older project by Ebbe Warburg, which was all about family resemblance and what he called Memnosyne, the pathos formula of similarities. And so he did that with a guy called Ernst Cassirer. And Ernst Cassirer is based on Leibniz in the same way, as network science is based on Leibniz. And so there's this common root of people that work with topology, with networks, and with these multidimensional embedding spaces. And so there's a lot of things we can do. And whenever, this is like what I'm saying here, whenever you encounter a humanist who's super reluctant regarding all these methods, you can be sure there is people in deep time, relatively speaking. 1929 is deep time for what we're doing, right? If everything that happens since 2013. So there's this kind of notion that we can basically rely on old ideas where people had similar thoughts. They couldn't do it because they didn't have the data sets and they didn't have the computation. And so we can be confident that it is a there in these data sets. and in these methods. And so the question is now sort of like how to sort of fund more of this kind of work, how to publish it, because is this an art history paper? Is it computer science? Is it physics? Is it information theory? If you publish it in entropy, who's reading it? And like all that kind of stuff, right? Yeah, so that's basically it. And then finally, yeah, this picture I used to show, I wrote a book chapter. It's called Cultural Analysisetus. It's openly available. It will be the first chapter of an upcoming book where all the proofs for this picture, if you take a picture, are there. So there's sources. This is actually true. Okay. This is where we are. So Tallinn University is here. Here is the old city of Tallinn, which is a hill, medieval, very nice. So nice that there is always minimum 3 cruise ships there that fill that city with 50,000 people for the day. So that harbor is 10-minute walk, 2 hours from Helsinki. It's 10-minute walk, our university, from the old city, and it's 10-minute walk to the beach, which is also cool. And it's 40-minute walk to the airport. Thank you very much.